Hello and welcome back to my series where I explain parts of this system. So in the last video we went over the road generation system, showcasing all iterations I made there, and finally an idea I had for the future, which is of course the V8 system. And right now in this video I want to showcase the type distinction system. Now I have two iterations of this, but the first one is not that interesting. The reason I started a second one was mostly because it started to become a mess. I lost overview, so I just decided let's start a new one, and that's what I did. So let's have a look here at the input we have. We start off with a road curve here. 2 in this case, so let's just scroll up a bit. This is the input I take. 2 curves are just hand-drawn curves, nothing special about them. I merge those together and input them to a system, as well as the terrain. Now the little bob here, I added that so I could kind of test my tunnel system, which you'll see later on. Now let's dive in. As you can see here, it's much better organized than the first iteration, and I guess let's just start at the top. So I start off, of course, with the curve resampled. So now I've got a lot of detail on this curve. There's a lot of points here, as you can see, and the terrain. So this is my input. First thing I do is I ray the curve on top of the terrain, so it's not very visible in here, but when we do this you can see that I have my road curves rayed on top of the terrain. They now match how the terrain looks. So what this is going to help me with is it'll help me to distinct where tunnels should be and where bridge sections should be. So in here you can see this is going over a mountain, so this should be a tunnel. It should go straight through. Here it goes down, and it should be a bridge. And that's exactly what I'm doing here in the first color pass. So here, based on the difference between this curve, which is the input, let's make this a bit bigger again, and this one, so I look at the differences between these curves, and based on the height difference I make a different color for them. Green being where the difference is positive, so that means that the curve is higher, and blue meaning that the rate curve is lower, so the distance is negative. Now the problem I'm having is 2 problems. First of all, you can see these little green sections here. Yes, they are there because the terrain has, it's barely visible even, but it has a very small bump when it gets off the river. So it bumps ever so slightly, and that causes there to be a, so to say, tunnel. I solve that later on, but what is also a problem is, as you can see, these river pieces are very small, and I fix that in here. Boom. So as you can see, it just extended. Let's turn off the terrain for a second. So what I did here is I used a for loop and some small piece of code that basically checks, okay, it goes over all the points and it checks, am I blue? If so, then make yourself, if my neighbors are blue, then I'm blue as well. But if I'm blue, one of my neighbors is blue, and another neighbor is blue as well, then color that neighbor blue. So I can adjust this in here. So right now I set it to maximum, and I can make it lower as well and higher, so you can see those blue sections moving. What I'm controlling here is basically the amount of for loops the loop makes. So it can, I like to have it at 10 right now. Maybe it needs to be even higher, but for now I'll leave it at that. So Another thing that is happening is this. So I'm taking the terrain as an input and adding a slope map. Now I guess the lighter the color is, the lighter the color is, the more slopey that area is. So you can see here they're very sloped and therefore they are very light. This color is also showcased in an attribute here. So if you go to the point attributes, make this a bit bigger, you can see a slope attribute. Now the slope attribute is used later on to kind of verify the tunnel sections. Not yet though. So moving on, I add intersection points. So as you can see here, between the green and red sections, it adds a point. And in this case, it's a lot of points. So why do I do that? Well, that's because I need to separate these sections. I need to make sure that the red and green are not on the same one, and blue for that matter. They all need to be different sections. So using these points, I make a bunch of smaller lines, and with that line, I make an intersection line. Now the reason they're kind of this pattern, they're following this pattern, is because otherwise the line that connects them, so all the vertical lines are the lines that I copy onto the points. The horizontal lines are lines that I make between them. If those lines would be diagonal, that would mean that it would cross the other line, the road curves, at multiple occasions more than it should, because here I'm intersecting them. So as you can see here, this is a good example. In between red and green, the line cuts it in half. So if we look in here, we can also see that points are generated. And if we turn on these point numbers, it's not very visible, but there's more than one point here, indicating that yes, in fact, it's now multiple primitives. If we turn this on and go here for a second, turn off the points, yes, in fact, they have actually turned into separate primitives. So now I have, for each section, a primitive. But still, I've got these small ones, so I have to fix those. And an additional problem, I have these faded areas, these gradients. That's because a point was made in the middle of them, so it has both red and green in it. Now that's what I fix in here. So when I click this node, boom, you can see that it's no fading, it's just boom, from red to green. How I do that is I loop over each section and I look at all points. I think I do that somewhere over here. Yes, I do. So I loop over all points and basically say, okay, if you're red, you're 1. Or I mean, if you're red, you're 0. If you're green, you're 1. And if you're blue, you're 2. So indicating the position in the vector. RGB 0, 1, 2. I later on use that information to add up. So if there's a bunch of zeros and only 1, 1, and even no 2s, that means there's one green point, no blue points, and mostly red points. That means that the red value is going to be the highest. With that, I then basically use a switch. So if the majority of points is red, then you just make the whole thing red. If it's green, then green, blue, blue. And with that, I make these more perfected curves. But again, I nearly forgot it in this system. I put this in last, changing in lines that are too short. This section speaks for itself. It looks at these types of lines and boom, it turns them red. Because it only happens with tunnels for some reason. I have not encountered this problem yet with bridges. If I do that in the future, I'll have to adjust this, but that's something for the future. This system also is not very complicated. It loops over each primitive section. It looks at the length and if the line segment is green and the length is below a certain value, it gets turned to red. That's basically it. So only the sections that are too small get turned into red, and otherwise they're just left alone. Now, from that slope earlier, let's just bring that up again. Right here. That slope map from the terrain, I transfer it to a curve, to the snapped curve, that is. So here we have our, we have our slope map terrain, and here we have our snapped curve. Now using a attribute transfer, I transfer that. So now you can see we have our slope map on top of our curve, and when I look on the geometry spreadsheet, I can see that there's a slope value as well. Now, as I said earlier, in certain sections I don't want there to be tunnels, for instance. And as we're looking right now, it would mean that in this section, tunnels would also be generated, where you could easily just build a road that is just slightly sloped. So that's what I'm doing here. I delete any sections that are not roads or tunnels. So here we've got all our tunnel sections. They are still snapped to the terrain though. And basically what I do is I check to see if their slope variable is high enough, or low enough for that matter. So again, I loop over a section. In this case it's still a road section. So here I have an attribute promote, which takes the point attribute slope, which has a value. So in these cases, I think it should be 0. Let me have a look at this. Oh, I can't see that here. Let's just look here then. Yeah, as you can see, it's very dark, so that's close to 0, very close to 0. So I take the attribute promote, and that basically takes all the points on this primitive, adds up their slope value, and averages it. So I get a certain value, which is now a primitive attribute. And if that attribute is too low, then I keep it as a road. And if it's too high, it gets deleted. So as you can see here, we went from having these kind of more high sections of tunnel. This one especially, this is a very sloped section of tunnel. You don't want this to be a road. So I delete it because the average slope is too high. And to kind of have everything look a bit better, I adjust the height here as well as fusing the points, because in here we have, before fusing the points, there is the issue of this. So you can see that here there's 2 points in the same place, but after the fuse node, that issue's gone. And I recolor it so that it's still red. The other sections don't need that. So when I go over the tunnel sections, you can see they're just the straight curves. Here we have the tunnel sections, or I mean the bridge sections, which are also still straight curves. And in one last step, I adjust the height of between tunnels and normal roads. So before this node here, adjusting edge height, you can see that this basically points up. It is remnant from the tunnel section, or the dividing of the curves, because this section was not good enough to be a tunnel, but it's still attached to it. So to get rid of this, I look at the neighboring point of this point and basically check, okay, are you connected to anything? No, that means you're not an edge point. So just take your neighbor's height. So it just plops it down, and yes, boom, it works. Whoops. And also it does a comparison, like, is the delta between me and my neighbor too high? If that's too high, then, you know, get that distance lower. So here I have a cheat switch, which is mostly for testing purposes. So if I turn this on, the whole terrain gets turned red. Sorry. So switching between them, it just turns red. and the whole RAID terrain works. This was just for testing purposes because I needed it for some part of the system, but I didn't take it out, I just left it in there. Now, that was the type distinction system. The only thing left right now is the tensor field system, which is probably the biggest one. So stay tuned for that. Again, video will be in the same folder as this video and the previous video was found. Thank you for watching, and I hope to see you in the next one.